So hi everybody. In this video, we are going to cover the second case here, which is inclusive open-ended class intervals. So we have already done the inclusive closed-ended in the first video. So now I'll be covering this. So let's just go to the question. Yeah, so inclusive open-ended class intervals. So as you can see, this data is inclusive. It ends at 50 and starts at 51 and not 50. And it is open ended also because we have and above here, right? The class intervals are not closed. So the question says that prepare a spreadsheet to classify the earned leave data of 100 employees of a government department at retirement. Classify according to following intervals. So the intervals are already given to you. You have to calculate the frequency. Then you are required to generate the number of earned leaves accumulated by 100 employees. The leaves vary between 1 and 300. You have to fix the values. Then you have to compute these statistical parameters such as mean, standard deviation, mode, skewness, kurtosis, median, largest value and smallest value from the ungrouped data. After that, they are saying classify the data on the basis of above class intervals to create a frequency distribution, calculate the mean and standard deviation of the grouped data, prepare a pie chart for the above frequency distribution. So let's go back to our Excel sheet and start doing the question. I hope my screen is visible to everybody. So as we did in the first question, we will have to generate random numbers first. So I'll write the command for that. Rand between. You'll have to keep a little patience. Just bear with me because I think the system is responding a little slow. Yeah. So rand between 1 to 300, right? Because they've already told you in the question itself that the leaves may vary between 1 and 300. Since we need data for 100 employees, so I'll expand it to 100, 10 by 10 ka square. Now these are random numbers, right? So they will keep changing. Let's say I change this one. See, the others have also changed. So that means we need to fix this data, which brings us to our second question, which says fix the values, right? So I'll copy them by pressing Control C. Then I'll just put my cursor here, go to paste, click on paste values. So my data is copied here and my values are fixed now. Now I can go on to calculate all the ungrouped values that they have asked. So mean, median, mode, what else? Maximum, minimum. What else have they asked? Standard deviations and kurtosis. Yeah. So standard deviation, skewness, and kurtosis. Right. So accordingly, you can start putting the formulas. For this, you'll write average, select your range, close the bracket, press enter. So you have your mean. Similarly, median. Again, select the range. Then we'll calculate mode. Selecting the range, closing the bracket, press enter. for max, we can use the formula max. Bracket closed, enter. For standard deviation, for skewness. See, for ungrouped data, this is going to be very easy, right? You just have to select the data range and they calculate it for you. For grouped data, which we are going to do after this, then you have to do few calculations manually, right? So we are done here with our ungrouped data calculations. Now we will move on to our frequency distribution, like classifying this data into class intervals, right? So I'll have my lower limit here, right? Then upper limit. So going back to our question, so we have 1 to 50 till 201. Then 200, and here we have and above, right? 51, then 101, 200 and sorry 151. After this 201, right? So this is what is given to us in the question. Now we will calculate our frequency. So select the whole area where you want the frequency and start typing your formula in the formula bar. So I'll type frequency, bracket open, select the data array, press comma. Now they are asking you for bins array, right? So since this is inclusive data, so our bins array will be same as our upper limits, right? Because there is a clear demarcation here that 50 will come here and any frequency which is 51 will go in the next class interval, right? So our upper bins are clearly defined in inclusive data. So we can select this as our bins. Now, one thing you need to keep in mind here, we do not include the last one which has and above, right? So we omit this, but please keep in mind that for frequency, we have selected this cell. So that means whatever is above 200 will automatically come here. But while defining our bins array, we do not include the last one, right? So I'll again go to my formula bar, close the bracket, and now you have to press Control, Shift, and Enter. See, I have my frequency now, right? So इसके बाद let's go back to our presentation. So if I look at my question, so we have done the fourth part, classify the data on the basis of above class intervals to create a frequency distribution. Now only fifth and sixth are left, which says calculate mean standard deviation and prepare a pie chart, right? So we already know that the formula for our standard deviation is sigma fx square divided by sigma f, right? So I'll just write it down for you again. Minus sigma fx upon sigma f whole square. Right, this is your variance and then this will become your standard deviation. So according to this formula, we will start calculating different values. So let's first calculate our midpoint, which will be our x. Right. So for midpoint, you will just start your bracket, then lower limit plus upper limit, bracket close, divided by 2. So I have 25.5 here. Now you can drag this formula till here, right? So you will get the midpoints. For this, as you see, we do not have a upper limit. So this we will again have to calculate manually, right? So for this purpose, we assume, right? जैसे यहाँ पे the difference is that of 50. So we will assume that 201 plus 250 divided by 2. We have to make an assumption here. So I'll start the bracket. This plus 250 bracket closed divided by 2. So 2 to 5.5, right? So this is the only thing that you need to keep in mind in case of open-ended intervals, that you have to calculate this midpoint manually, right? So next we can calculate our fx. So fx will be this into multiplied by this, right? So I'll just drag this here. When I get this cursor, simply drag it and you will get the value for each case. Now we can calculate fx square. To convert this into superscript, I'll press Control 1. Please bear with me because the system is taking a little time today. Yeah. So I'll click here on superscript, press OK. So this is converted to superscript here. Now, if I have to calculate this, for that frequency multiplied by x and again multiplied by x, right? So I'll simply drag it down, right? And I think this is it. That's all we need, right? I'll take a sum of all these things total. So sum, this should come to 100. So that means we are going right. And we'll need, sorry, a sum of fx now because we need fx square. Similarly, sum of this column. Yeah. So now we can proceed on calculating our mean and standard deviation. So this will be sigma fx by sigma f, right? The formula. So I'll just divide this by sigma f. So my mean is 132. Then I'll start calculating my variance. So for formula for that is sigma fx square divided by sigma f bracket closed minus, I'll again start an inner bracket. So sigma fx divided by sigma f. Now I have to take a square of this, right? So this bracket closed, right? Yeah. So this is my variance. Now I'll take a square root of this. We can do this in the same formula. I just don't want to complicate the formula for you. That is why I'm doing it separately. So this cell, enter. So this is my standard deviation, right? And yeah, so that is it, right? I'll paste my ungrouped data analysis also nearby the grouped one. Let's just cut it from here and paste it here, right? So if you see here, there is a significant difference between your mean here and mean here, right? One reason might be because we have open-ended intervals, and there are 23 figures frequency which is lying above, right? So there might be figures which are above 250 also, right? So that is the reason why we have a difference here. Even in standard deviation, this is 73 here, and here we have 81, right? So for ungrouped data, the variance or the pattern according to which the data is distributed, right? So that is higher. The variability is higher in case of ungrouped data. Now we are left with only your pie chart. So go to insert. Anyway, I hope everybody knows how to make a pie chart. So this would be just kind of a revision, right? Yeah, so here we have pie charts. First, let's select the data. So this is what we want our pie chart for. We'll select this one. You can choose anyone, donut also or 3D pie chart. So that is up to your creativity. Yeah, so you have the chart here, right? So you'll have different options here, right? You can edit them accordingly. You have, if you see here on the design tab, right? You can change the layout. Here you can have figures also, right? So in 1 to 50, you have 22%. So on and so forth. You can change the colors from here. You can change the layout, right? So that is up to your creativity. So this one here, and you can edit this portion also as results. And you can uh, color these cells or change the background or do whatever, right? Yeah. So that was it about your inclusive and open-ended data. I'll just stop recording.